Hello everyone, welcome back to our channel. Now let's see the second part, module 2 of computer organization and ARM microcontroller 21EC52. For the model question. So module 2, describe the following addressing modes with an example. So these are the addressing modes that you have to explain with example. So determine what is register addressing, direct addressing, indirect, index. So each of the marks, that is register 2 marks, direct 2 marks, indirect 2 marks, index 2 marks. So each subheading will have 2 marks and with an example carries the another 2 marks. So totally it will carry 10 marks. So here whatever the marks that has been specified, please don't mind. This is all for 10 marks. And then define stack. Explain push and pop operation on the stack. So we have to define what a stack. If you want to define the stack with a diagram, well and good. And then explain what is push and pop operation with an example. Then consider the register R1 to size 16 bits with initial data. So here you are considering the register. Here itself I will explain you how to do this. So you are considering a register R1. So that R1 register can occupy 16 bits of data in the R1. So 0, 0, 0, 0 like that, 0 to 15 bits of data can be occupied in the R1 register. So where they have specified that the initial data will be this. So now what has to be done is, with neat diagram, depict the output in each case after performing the following operation. So with this initial data, you have to perform left shift by 2. So this data should be left shifted by 2, comma R1. This has to be left shifted by 1 R1. So you have to rotate the data by 1 to R1. So that will be moved to the register. So that is what you are going to do this. So totally it will carry 10 marks if each and every explanation is given properly and derived. Moving on to the next question, that is the first question, tips. So register, it is nothing but you're going to move R2, R1. So the instruction in R1 will be moved to R2. Direct, so you're loading R1, 5000. It means that this value is loaded to R1. Directly it is being loaded. Indexed means the value that is in the memory location R2 plus R3 both will be indexed together and then will be loaded to R1. Register indirect is nothing but the R2 will be directly moved to, that is it will not be directly moved to, the address will be located, then the value in that address will be taken and moved to R1. So these are the 4 addressing modes, and with example you can quote it down. Next, moving on to the stack. So push and pop, this is for push operation, that is you are going to load the data into the stack. What is stack operation? It has push and pop. Stack is where you're completely storing the data. You can otherwise call it as it is a memory that is completely storing the data. Then here push is nothing but the lowest number register will be at the lowest address. You are going to push the data. So here R1 will have the lowest address, R4 the next highest address, R7 the next high. So you're going to push the data into the stack. Pop, it means that you're going to take out the data. So see here all these registers, the address contents in this address is taken out and it is stored in some other register, that is called as pop. So you can draw it in complete diagram and explain for 10 marks. Next, our choice, consider a database of marks scored by students in 3 tests stored in memory starting at address list. So list is the address. You are going to store the marks scored by the students in all the 3 tests. So each of the student record consists of student ID followed by marks in 3 tests. So with the ID as a specification, you're going to enter the 3 test marks. Now you're going to assume each of there to be 4 bytes in size. So each test marks will be 4 bytes in size. So there are 50 students in the class and this value will be stored at location. Now num. So here now you're going to take a address and keep on incrementing it to add the specified ID with the 3 test marks, and the consolidated 50 students class value will be added in the location num. Now you're going to sketch how the memory mapping will be done, how an ALP, that is assembly language program, can be returned to using indexed addressing mode to compute the sum of scores. Okay, so you will be using the indexed addressing, that is, now when you are using list as one, list 1 will be the first address, then list 1 to list 49 will be indexed, list 1 plus list 49 will be moved to some other register. You have the value of register num, that will be moved. So you have to write an ALP program for that. And the second one is define subroutine with a program segment, illustrate the parameters passing using the register. Then explain the memory operation with the example. So subroutine and memory operation, I'll give you the scheme. So this is the memory operation. You have data memory and instruction memory, where data memory is SRAM, how it has been splitted with number of bits 0 to 7, 0 to 7, 0 to 7, it has been shifted. You have RAM, and you have a control unit where the RAM is carrying out to the SRAM, and then there is an instruction memory where you're going to store the instruction that has been sent, move R1 comma R2, add R1 plus R2. So all those will be stored here. And here the this is what you have to draw and explain in detail for 10 marks. And subroutine, when you calculate, you have to write subroutine is nothing but it is a loop process that has been followed in the programming to attain a result. So you will write what is subroutine, and you can write this as an example, like in main a and b value will be given, and you're calling for subroutine. So how you will be calling for subroutine is call subroutine a comma b. So you will be calling a comma b until it is been printed. So you will be subtracting x comma y will be done. Again, when you return, it will come into the subroutine class until it prints 1 and 2. Yes, this is what the example for subroutine. Hope you have understood the small tips for the solution. Hope this will help for your tomorrow's exam. Please be stay tuned for more information. Thank you.